Hello friends, how are you doing? As you step into grade 10, you will encounter this concept called resolution of vectors in physics. And learning this concept well is going to help you in acing the physics in 10th and beyond in a nice way. How do we understand this resolution of force? Let's assume that we have a ball. And let's assume that you are applying a force in the horizontal direction. What do you think is going to happen? The ball is going to move under the influence of the force. Now let's forget this force and assume that a force is now acting in the upward direction. What is going to happen? As you rightly guessed, the ball is going to move in the upward direction. Now let's bring back the original force and apply both the forces simultaneously. What do you think is going to happen? Under the influence of both the forces, the object is now going to move in a diagonal manner in between both the forces, right? So it is very important to remember that when simultaneously both the forces which are perpendicular to each other are acting, the body is going to move in a diagonal manner in between the forces. It's as if these forces are not there and the object is under the influence of a new force. This force is what is called as the resultant force. This diagram depicts what we just now saw in the animated video. This is the ball under the influence of two forces Fx and Fy, and under the simultaneous action of both the forces, the ball moved in this particular direction. It was as if it was acted upon by this force Fr, which we call as the resultant force. Now, I want you to consider one scenario. Assume that the ball is there and actually this is the force F that is acting on the ball, right? So, under the influence of this force, the ball will, as expected, move in that direction. Now, assume that we want to break up this force into two forces, one along the x-axis and one along the y-axis, okay? It's like the converse of what we saw earlier. Earlier we had two forces and we got the resultant. Now those two forces are not there. Assume that this is the force that is there and we now wish to break up this force into two forces, one along the x-axis and one along the y-axis, right? So that is what is called as the resolution of this force along the x-axis and y-axis. I hope you understood this. What we will do now is to find out how to compute those forces, how to replace this force with the Fx and Fy. To do this, what we do is we draw a perpendicular from the force onto the x-axis. Assume it is touching at this point. Let's call this 0 and A. And likewise, let's draw a perpendicular from the arrow to the y-axis. Assume this is touching at the point B, right? So this particular length, that is OA, is what is going to be the force along the x-axis or Fx, and this particular length Fy is what is going to be called as the horizontal component. So now we are left with how to compute this length OA, how to compute this length OB, which would in turn mean Fx and Fy. So if you look at this, friends, this force is making an angle with respect to the x-axis. Let's call this angle as theta. Alright, so if you consider this triangle OA, let's call this point as C, OAC, right? What would cos theta be? You see, I want to calculate this side, which is the adjacent side. Adjacent side for me is OA. OA is nothing but Fx, okay? How will I compute this OA? I will use this ratio cos theta. cos theta is equal to OA divided by OC. Is this clear? Now what we do, we replace OA with the force. So cos theta is equal to Fx by hypotenuse is nothing but F, okay, and therefore Fx is going to be equal to the original force F multiplied by cos of theta. So we are making use of triangles and a bit of trigonometry basics in order to compute this component of force along the x-axis Fx as F into cos theta. And likewise, in order to find the force along the y-axis, okay, we can realize that OB is nothing but AC, right? So both these are equal. So we have to compute AC. So for doing AC, what is the trigonometrical ratio we need to use? As you would have guessed it, we need to involve the opposite side. So we'll say sine theta. So sine of theta is going to be equal to the opposite side AC divided by our hypotenuse OC. AC is nothing but Fy and OC is nothing but the original force F. Therefore, Fy is nothing but F into cos theta, F into sine theta. So Fx is equal to F cos theta, Fx is equal to F sine theta. These are the two forces which we were seeking. In fact, breaking up this force F into F cos theta and F sine theta is what is called the resolution of the force.